Man. Oh, I just noticed it hasn't been picking up my voice this whole time. Oops. Well, that's a shame. Anyway, you've just been hearing me whine and moan about how complicated everything is. Ah, there we go. Hey, great, finally, I got that open. So now I can do this and that and this. Okay, and then, oh no. Man, this is so broken. I'm just checking, okay. All right, you know what? This terminal is now forfeit. Let's open a new terminal. Well, actually, no. Okay, here's what we'll do. Let's put on our bash terminal again. No, that's not right. Oh my god. Man, everything is so difficult. Oh, what? No, that's not it. Wait, what's going on? Oh, okay, this is the right one. Okay, so yeah, this other terminal is just dead. I can't do anything with it because it doesn't support Control Z, and I forgot to start it with the ampersand. So, but it's okay because now that I've started it, I should be able to run make from inside the editor. So now if I do Shift F9, hey, okay, great. Although I do need to get rid of this stupid okay, yeah, so this ARPA INET, I actually shouldn't need it. So, oh yeah, I still haven't explained what I'm even doing. So, uh, let me see. So, what's the best way to explain this? Maybe if I open up my... Man, I don't know how to explain this quickly. I guess I'll just go explain it slowly then. So let me just walk through the main function here. This OS common startup comes from this oscommon.h. Now this is a file that I actually wrote for myself a long time ago. Basically what it does is if you're on, oh, that's common.h, not os common. If you're on Windows, if Win32, Win64, blah, 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 I include WinSock, and I make all these like Windows versions of functions. This OS Common Startup is this ridiculous WSA startup junk. Like, oh my god, right? OS Common Cleanup. For whatever reason, this I used to need to do this in MinGW. I used to actually have to define the pollFD struct, but it seems to have fixed itself at some point. Yeah, you can see this is a file I did a long time ago. This is 2 years ago, 3 years ago. Anyway, yeah, doing poll. And now here, I'm just making some defines. Sockster error, get time of day. For Linux, it's actually easier to see what's going on here. I just defined this close socket to be closed, this fixRC to do nothing, sock errno to be errno. And the point is, after using this header, you've got a relatively straightforward common API that you can use between Linux and Windows. Now, actually, I haven't compiled this in Windows before. This is the first time I'm trying it. And but I did go to the trouble when I wrote this code to use this oscommon.h so that hopefully it would just work in Windows. So at this point, the following API can be used on either Linux or Windows. You can use poll except for a stupid Microsoft bug, which I'm kind of not doing this at all because I'm using libevent, which kind of hides that behind the scenes. You have to use sockfd instead of int. You have to use close socket instead of close. You have to use invalid socket instead of -1. Get time of day now exists on Windows. Now wait a minute. Why did I do that? Wait, hold on. What's going on here? Oh my god, I forgot. I don't have man pages. Man, this is so... Developing on Windows is always such a pain. What is this fixRC stuff? Yeah, none of the socket calls return the error code. They leave it an error node. They always return -1, right? I'm just checking all the man pages here on the... Yeah, on error, -1 is returned. So I don't need this fixRC. Well, I'm not going to edit this file. I don't really want to edit it right now. But anyway, the point is that I wrote this code all with OS-Common in mind. And OS-Common startup, on Linux, this does nothing. On Windows, this does the WSA thingamajig. Now, this TCP-cons is a global variable, which I believe is defined in common.h. Now, there's two important types in common.h that we'll talk about. These are actually the only two data types in the whole program. There's this TCP-con, and there's this tunnel to another computer. Lua refcon is because I'll explain this later, but when you use the Lua CLI, you can use these objects as user datas in Lua, which I'll explain later. So I need to maintain a ref count to make sure I don't free this object too soon. Next, tunnel ID, I'll talk about that when I talk about tunnels, but this is just so that every tunnel gets assigned a unique ID. And then we have the file descriptor, a status code. Let me show you the status codes. It's pretty simple. They're in this enums.h. Oh, I did it with the X macros. I forgot about that. So I basically have 4 status codes: connecting, connected, error, and closed. Yeah, that's what the status E is. And then I just have some information about what this TCP-con is connected to. This is the buffer event. This is from libevent. This is what I use to manage the data and connection and all that stuff. Now this is for parsing messages. Basically, I don't assume that we always get a complete message in one burst of data. So I use actually these 5 variables to parse messages. I have my own custom protocol on top of the TCP layer that is used for managing tunneling. And then every TCP-con has a linked list of tunnels. So inside the tunnel struct, we've got previous and next pointers. And this is just a sentinel. This is a trick that I saw in Michael Labrash's graphics programming black book, which is that having a Sentinel element for a linked list is super clean. It helps a lot. Actually, you can do a little bit better. This is something I saw later when I was looking at some Linux kernel code. You can use a trick called, well, I don't know what it's called, but anyway, in your own time, go check out list head from the Linux kernel, and you'll see what I mean. But I decided not to do that here. I just have a complete tunnel struct, and I'm only using the previous index pointers as a sentinel. I don't really care about the extra memory. And then finally, the previous index pointers so that these TCP cons can sit in a list. And I have a global list of open TCP cons. And yeah, I really, people say, oh, don't use global variables, yeah. Wow, well, screw off, because, all right, I'm writing this code. I know it's single-threaded. I know I'm never going to bother to multi-thread it, and this just makes things so much easier, okay? Yeah, so what I do here is I just initialize the linked list of TCP cons. Yeah. Okay, then what I do is I start a Lua CLI. I just open up the base functions from Lua, which is stuff like do file and version and stuff like that. And then I have this function that I wrote, Lua Open Tunneler. What this does is it loads all of the Lua CLI functions that you can call to use this tunneler program. And I've defined the Lua API in this markdown file, which is still kind of a work in progress here, but it would be best to look at this file actually in a rendered markdown. So how do I do that? I think if I do this, and then that, and then this, and then that, and then this, and then that. So many steps. Okay, great. So Lua CLI. Okay, so TCP_con. This is a user data in Lua that manages one of those structs. In fact, one of these structs. And likewise, tunnel manages one of these structs. Okay. Should I explain what tunnels are? No, I'm just going to assume you know what that is. I'm going to move on here because I want to get to coding soon. And so the API functions are connect. This is how you create a new TCP con. So you give it the ports and the IP address of the host you're trying to connect to. Once you have an open TCP con, now you can do some interesting stuff. You can create a tunnel just like you would in SSH. I haven't written this yet, but in principle, you can also do a reverse tunnel. I also haven't written this close function yet. It actually, for some reason, the closing logic is kind of complicated. I don't really know how that happened. I haven't written the quit function either for the same reason. I have written list connections, which basically just goes through the global linked list of TCP cons and pushes them all as user data. I have list tunnels, then parent of tunnel. Actually, I don't think I wrote this, but anyway, it gives you the TCP con object that a tunnel is associated with. There's some status information. I have some pretty printers as well for the user data, and some other just getters that you can use to get fields of the objects. And I haven't implemented this yet. Yeah. Now, there's only going to be one TCP connection between your computer and another computer. Why don't I talk about this in a second, but let me show you the Lua CLI now. So these are all the Lua functions. And actually, let's talk about the management of user data quickly. So this push TCP con does exactly what you think it does. Given a pointer to a TCP con, it pushes a user data for it. So first what I do is I create a new user data that's just big enough to hold the size of a TCP_conn pointer. Then I set a metatable to TCP_conn. This metatable is defined in the Lua Open TNLR function that we call to start everything up. So, sorry, this Lua Open TNLR. Maybe I should show you that, but first all right, fine, I'll show you that. So basically, these are the API functions that I have implemented. All I'm doing is I'm registering them as global variables or like functions that are globals that you can call. Then I define this metatable TCP_conn. So I hook up a toString and a GC function. This GC function is all important, of course, when you're coding in C. And then here, just as a little trick, I push all of these same like tunneler status. Oh shoot, I don't have that preference turned on. 1 second. Where is that? Where is that? There's something you can do in Genie. If you select an identifier, it'll highlight all of its instances. Where is that? Oh man, maybe this version of Genie that I'm using just doesn't have it. That's a shame. Well, I'll just have to live without it. I do think at the very least though there is a keyboard shortcut you can use that will mark all instances of an identifier. Yeah, mark all. Shift Control M. So Shift Control M. Oh, there we go. Yeah, so basically this same tunneler status that I use up here for the status global function, because its first argument is a TCP_conn, or it could also be a tunnel, I push it inside this TCP_conn metatable so that you can use that nice syntax with the colon. And likewise, I do the same thing for localhost, local port, etc. And likewise, I do that also for the tunnel metatable. Yeah, okay, fine. So then now I can go back to showing you that push TCP_conn. This is important. The management of Lua user data is quite tricky, and this is a solution that I've used in other projects that seems to work for me. So anyway, I push this user data that basically just contains the pointer. Like it's just big enough to contain the pointer, and I basically memcopy the pointer right into the user data. And I give it a metatable of TCP_conn, and importantly, I increase the Lua ref count because I've now created a new reference to this pointer. And I just have a little debug message here to help me troubleshoot. Like this push tunnel is exactly the same. Actually, when I do Lua stuff in C++, this function is a template function. And it's pretty nice, actually, I gotta say. I really like templates. Why did I do this in C? I don't know, maybe I just felt like it. I don't know, I can't remember. I started this project a long time ago. Now let's go take a look at the GC functions because that is no walk in the park. Where is that? TCPCon GC. Oh man. So first what we do is we check that the first argument to this function is a TCPCon using this check U data. And if it is, we save it in this local variable here, TC. The U data is just a pointer to a TCPCon in that global linked list. We then decrement its Lua ref count. If the ref count goes to 0, we need to see if it is safe to free this TCPCon. There are 2 reasons why it wouldn't be safe, and we need to check for both. 1, we need to iterate through the list of tunnels and check if any of them still have Lua references. The reason being that given a tunnel object, you can call this parent to then get a Lua reference to the TCPCon object. And then 2, we need to check if this connection is still open. So even if there's no tunnels, if the TCP connection is open, then this list connections can get a reference to the TCPCon. So I decrement the ref count. I print it out for debugging. I assert that it's greater than or equal to 0 because, well, that's just for my sanity. And then if the new count is less than or equal to 0, the less than is just a failsafe that really doesn't do anything. But if the new count is 0, if this TCPCon is still in use, then just don't free it. If any of the tunnels under this TCPCon have a Lua reference, then we'll still hang on to it. So this is what it looks like, by the way, to iterate through a linked list using the Sentinel approach. Well, it has to be a circular linked list, by the way, but it's really nice, actually. It's very, very nice. So you start initially by going to Sentinel arrow next. If the list is empty, then this Sentinel arrow next actually points back to the Sentinel. And then what you do is you iterate until your current pointer does not equal the Sentinel. And then just increment by following the next pointer. But yeah, anyway, here I check if any of the elements in the array have a ref count greater than 0, then we just return 0. But finally, if we make it to here, it's because there's no reason to keep this TCPCon alive, and now we can free it for real. So let's go take a look at this function. Yes, okay. Make sure that we don't free this Sentinel. That would be bad. Also make sure that we don't free a TCPCon that still has Lua references, which I don't think is even possible, but hey, we have it anyway. Now we've removed this from the linked list using the usual linked list modifications. Then I free all of its tunnels. Let's just take a look at this function. It's pretty simple. It's very simple. We iterate through and call tunnel free, which I'll show you in a minute. Then we just free the rest of the fields inside of the TC. So, I forgot to do this. I think at some point it is possible for me to free this message data ahead of time, and if so, I'll mark it as null. And then, likewise, just make sure that we're not freeing things. Well, I mean, if it's null, then the free function will ignore it anyway, but I don't know. And then we free the buffer event, we free the remote host. Yeah, and then we just free the struct itself. Now, let's look at this tunnel free because it's quite similar. So, tunnel GC and TCPCon GC are very similar. We obtain the tunneler pointer, or sorry, the tunnel underscore t pointer from the first argument to the function. And now here, tunnels. This is a mistake. There are 2 reasons why it wouldn't be safe. And we check for them. So if the connection is still open, then we can still get a reference to it from list connections. But actually list tunnels Oh, but, No, no. Well, I'll just write it anyway in a comment because it's not obvious. If the TCPCon parent of this tunnel still has Lua references, then we could use list connections to find this tunnel, except no, because we're about because if this tunnel is not open, we're going to remove it from the TCPCon's list of tunnels anyway. So list tunnels wouldn't find it. I know that doesn't do anything, but it just kind of, explains what I mean. Yeah, okay, so actually I don't need to change anything. So yeah, the only reason that we would want to keep a tunnel open is if it's still connected or connecting, I guess. But otherwise we go to tunnel free, and tunnel free is kind of what you think it is. We make sure that we're only freeing things that are actually closed. We make sure that it actually, that the ref count makes sense. And then we free the fields. We remove it from the linked list, and then we free the thing itself. Okay, great. So I have now talked about the Lua CLI. I've talked about the basic structure. The only thing I haven't talked about is how it actually works at the low level. In other words, how we perform tunneling over a single TCP connection. So that's the last thing we need to talk about. And the way to talk about that, the most easy way, is here in Lua Open Tunneler, we have two functions, connect and tunnel, that start this process of doing TCP connections and tunneling. So these are very complicated functions, a lot is going on. So I'm just going to very quickly go over them. And actually this will also be a way for me to double check that the way I'm using OS Common is correct. But let's read this comment. Check if a connection is already open to the desired endpoint. If so, just return that, taking care to increment the ref count. Otherwise, allocate a new TCPCon object with status connecting. Create a new socket with O non-block and bind it to the given local port if that was requested. By the way, we will check for errors everywhere. After that, we will parse the host and port into the right format for the socket and issue the connect call. Finally, we hook up a lib event so that the callback will update the TCPCon status once the connect finishes. Okay. So first, we check the arguments to the function to make sure that they make sense. So the arguments are a remote host, an optional remote port, an optional local port. So we have all these checks that the inputs to the function are saying. I'm just not going to talk about that. Then here we iterate through the existing TCP connections and check if any of them match, and if so, we just immediately return. And here's a little thing that I did here. Oh yeah, okay. So if we find a TCPCon that was dead, in other words, it's neither connected nor connecting, then actually we don't need to allocate a new TCPCon or even edit the linked list. We can just use this cur instead of allocating a new TCPCon. But if we find no such cur, the way we would know that is the loop breaks because we made it all the way back to the sentinel, and then we can check for that in this if statement. Then we allocate a new TCPCon object. Let me just put a little to-do here to something I need to check. check if I need to free any of the fields before reusing prevent memory leaks. So anyway, here, if we didn't find an existing connection, then we will actually malloc a TCP con. Also, I should really make this cloc. Okay. And then we put it into the linked list. Yeah. Initialize the other fields. Yes, that got remembered because I always duplicate the string when I save it into the struct because, you know, who cares? It's a tiny amount of memory, tiny amount of performance. And then I create a new ev buffer for message data. I set the status to connecting. I set the local port, which I guess I already did up here, but whatever. I initialized the tunnel list to be empty. Then what's going on here? I make a non-blocking TCP socket, and for each of these things I check for errors. I'm not going to go into the error checking. Then I used to use the set sock opt, but it turns out libevent has this super nice function that figures out how to do this S over use address in Windows, which is just an absolute nightmare. So thank you, libevent. And then I have no idea if this reuse port is something that does anything in Windows. I don't know. But anyway, by this point, we now have a socket that we can use. We save it inside our TCP construct. And then we bind it to the given local port, taking care to throw errors if anything went wrong. Then we use this inet p2n, which I believe, by the way, so that inet p2n, shoot, I shouldn't have done that. Go back. Okay. That's from this arpa inet.h, but actually, as you saw earlier, I do define it inside this oscommon.h. Where is that? Right here, inet p2n. So I actually should just be able to simply get rid of this arpa inet.h. But anyway, so we use inet p2n to make this sock address, or this, not sock address, sock address, so that we can finally start this, wait a minute. We create a new buffer event with this opt close on free, which is super nice. I'm so happy this exists, because when I do a buffer event free, I want it to close the socket. I don't want to fiddle around with that. And then I set the callbacks. So I'll talk about these callbacks. This TCP-con read callback is the most complicated function in the whole program. So yeah, we'll have to deal with that at some point. No write callback because I don't care. A connect callback and oh wait, that's not right. Isn't this supposed to be an error callback? Yeah, it is an error callback. But I'm using it as a connect callback. Oh, interesting. So this is actually the function that gets called when the connect event happens. And let me see what I'm doing in this function here. Oh yeah, I basically just copied this and edited it. So oh no. We'll just go ahead and do that. Okay, that's not bad actually. So then we set some timeouts. I only want a 10-second timeout for starting TCP connections. The reason being that, how do I explain this? I use the, oh shoot, what is that called? It's like, TCP simultaneous open, I think is what it's called. Yeah, so if two if two endpoints send SYN to each other, usually the OSs will actually start the TCP anyway. You don't need like a specific read or a accepting socket or anything like that. So I make use of simultaneous open because the whole point of this is to do hole punching through the network address translation in the routers. So yeah, that's why I only want this to be a 10-second timeout, because if it does depend, because we're doing hole punching, it does depend on both people connecting at roughly the same time. And I don't want you to just sit there for hours like waiting for the default connect timeout, which I think is like 20 minutes or something, to try it again if it doesn't work, you know. Okay. So I set the timeouts, and then finally I issue the buffer event socket connect, which will call this connect callback either for an error or because it actually connected. And then I push this TCPcon to the Lua stack, because this is a Lua function that returns a TCPcon, and return 1 because we added one item to the stack. The tunnel function, oh man, I really don't want to explain that line protocol, but I probably should, shouldn't I? Fine, we will do it. So the line protocol is implemented in this TCPcon read callback. Now brace yourself, because this is a complicated function, and it was partly debugged into existence. So now we need this line protocol. So first let me talk about, so what do I mean by line protocol? I have a TCPcon, I've connected it to a remote host, and using that one TCP connection, I have to multiplex all the data that's being sent on that TCP connection to the correct tunnel. So I have a very simple protocol to use on that TCP connection to manage tunnels. So I just have a couple of stuff here. So any multi-byte field is a network engineness. All messages have an 8-byte header followed by arbitrarily long data. The first 4 bytes of the header is the type of message, which is one of these, and the second 4 bytes is the length of the data, which can be 0. And then here's the messages. So open tunnel, I put the port and ID and all this stuff. Oh, I guess I do need to talk about the IDs, because that was another complicated thing. Oh man. Yeah, this is a case of a project being like, I thought this would be simple, I really did. Because it seems so straightforward. It's like, just make a TCP connection and shuffle the data around, but there's so many corner cases. And trying to keep the structure of the code nice has been an absolute nightmare. Just trying to keep things clean and not have them become spaghetti code. I mean, I don't think the spaghettification level is too bad right now, but it's getting there. Anyway, so the data on an open tunnel message is 32-bit ID, so every tunnel has a separate ID, so we can refer to it. And this is where, this was the number one thing that I just didn't think about when I was first designing the line protocol, is that we need to have unique IDs for both endpoints, which is, so the reason is because let's say that one endpoint opens a tunnel and then another endpoint opens a tunnel. If they have the same ID, now, well, okay. If one endpoint opens a tunnel, both sides of the TCP connection need to make a tunnel T-struct and put it in the list of tunnels. And if those both have the same ID, or they have to have the same ID so that we can send data to the right place. But if it is possible that both endpoints will create a tunnel with the same ID, and then both endpoints will have 2 tunnel objects with the same ID, and just all hell will break loose. So I have this really ugly trick where whenever we send an ID to the other host, we always toggle the MSB. And this guarantees that the same ID, like the same, like the ID, how do I say this? Both ends of a tunnel, in other words, the tunnel underscore T object on both ends of a tunnel, the MSB will be different on both ends, guaranteed. Does that make sense? I don't know. This was, I mean, I had to go through a lot of iterations before I finally settled on that solution. And it's not a very easy to understand solution. Anyway, I'm getting mired in the details here, and I just want to move on so I can do some coding. So, yeah, okay, so we send the tunnel ID so that we can refer to it later. A 16-bit port number and a remote host string. The length of the string is deduced from checking the length field of the header. Fine. Open reverse tunnel, this isn't implemented yet. I'm skipping over it. Open tunnel response, this is how, well, okay, so L is, so I guess I should explain this. In these descriptions, L is the tunneler instance on the local machine, and all descriptions are from its point of view. R is the remote tunneler instance. So here, R uses this type of message to notify L about the result of an open tunnel or open reverse tunnel request. The data is the 32-bit ID that was sent with the request so that L can tell which request this response is for. The next 32-bit value is a status code, and right now I'm just using like 0 for success and arbitrary negative numbers for different errors. Now, this is the really interesting one here, tunnel data. And what's interesting is that it's symmetric. L or R can use this in the same way. The data is 32-bit tunnel ID that was given in the open tunnel message, and then followed by whatever data is supposed to go to that tunnel. So the header's size field will be 4 plus data size, 4 for the tunnel ID, and then data for the data that we're actually sending. And then, you know, closed tunnel, closed are just to close things. And then debug message is something that I added in at the last second because I needed it to debug. It just prints a string. And then I may add more features later, like I do want to support encryption. That might be what I'll work on today. I was reading the Luby-Rakoff paper about proving that 3 applications of, I don't know what you call that, but you can create a pseudo-random, like a provably pseudo-random permutation from an assumed random or an assumed pseudo-random function, even if that function is not a bijection. And basically, there's a trick that you can do that you can apply it 3 times, and by applying it 3 times, it becomes provably pseudo-random or something. Anyway, I'm starting to stray into some other thing that I might work on today, but I'm almost done talking about the line protocol. Okay, so TCPCon read callback. This function gets called every time some data arrives on a TCPCon. And this is where all of those parsing state variables in the TCPCon header or TCP construct become useful. So I guess I should briefly say here, the void pointer argument I use when I set up the callback is the TCPCon, so that's what I'm doing here. And then I get this F buffer for the input. Now, depending on the state of where we're parsing, well, we have to do different things. So if we're going to try to read the header, we pull up 8 bytes because the header is always 8 bytes. If we were not able to pull up 8 bytes, then we just need to wait for more data. There's nothing we can do right now. Otherwise, we, what is this temp? Man, I shouldn't have called it temp. I should rename that. Message type. And then this is the message size. So I get the type and the size from the 8-byte header. Now this is important. This is not an else if, because suppose we read the header successfully. Now we will update our state to read data. And now we try to read data. So try to fill the buffer. If the buffer gets filled, we set the state to tcpcon exec message. Otherwise, we return and wait for more data. So now here what we do is we do this remove this ev buffer remove buffer, which no, I don't have code hints for that. So buff, what is buff? Oh, that's the event buffer. Shoot, I usually call this bev. Okay, stop, go away. Oh, stop, go away. Okay. Whatever, let's not change it. But anyway, so we read from the buffer event into this TC message data. Now, I know I went over this at lightning speed earlier, but this message data is just it's an ev buffer. It's just a temporary buffer where we're going to store the message data that we're working on. Yeah. I'm just going to keep describing here because I just need to move on. So I keep track of how much data we've read so far. I have this assert statement here. And now here, if the amount of data we read so far is equal to the size, the expected size of the data, which we set up here, by the way. So this data size member of the TCP construct is what gets set from the message size field of the header. If we have collected all the data that we want, we then go to this exec message state. And now this is where things really go off the rails for code cleanliness. Yeah, you see here, to do, clean this up so it isn't a hundreds of line long switch statement. Yes, that is something I should do. I have a little debug print message, and then I collect the message type, and I cast it to an enum so that I get the nice checking from the C compiler that I test all the values in the enum. And basically for each message type, I do what it says. So I'm really not going to talk about these. I'm even going to close the case statements so I don't get tempted to talk about them. I'm going to code fold these. So for close, I guess I try and free everything. I have to, oh, again, I should do this, shouldn't I? Ugh. Yeah, close is not implemented well right now. I don't even have the Lewis CLI functions for it. This close message just doesn't do anything. Yeah, this is pretty bad. So this is a big to-do. Open tunnel. Now, keep in mind, this is when we receive a message. This means that the remote computer sent us an open tunnel message. So this will go through, you can see here, this is 100 lines of code to start the tunnel opening procedure, and this is not simple. Tunnel data, this is actually simple and important enough that I will show it to you. It's very simple. I don't know why I used pull up for this. Oh, yeah. So I pull up 4 bytes just so that I can get the tunnel ID. So that's what this data is here. I just want the tunnel ID, and then I drain those 4 bytes that I pulled up. And then, oh yeah, I should show you this find tunnel function. So why is this here? Oh, I see. So, all right, I look for the tunnel pointer. So find tunnel is exactly what you think it is. Given a TCPCon and a tunnel ID, I iterate through the tunnels linked list until I find the given ID. So nothing too complicated there. Once I have the tunnel, I then get its buffer event because I saved the buffer event pointer in the tunnel object. And then, so you see what's going on here? I find the ID, and then all I do is I take that data and I write it into the tunnel's buffer event. Yeah, this is a weird way of doing it. I don't really know why I did it this way. Like, I kind of want to clean this up. So here it's just going to be tn arrow bev. Yeah, so here I take all of the data that we saved in that ev buffer that we saved over this business here of tcpcon read data. And then, yeah, we put it into the tunnel's buffer event so that we actually send it to the tunnel. And that's pretty much it. Now I'm pretty sure this buffer event write buffer will actually drain the data. Like it's an implicit ev buffer drain. I'm pretty sure. So what I do is I set the data size to 0, and the reason is because I have some common code at the bottom of this switch statement right here that just drains whatever's left inside the buffer and sets the state to read header. Because this tunnel data happens to drain all the data, I just set the data size to 0 so we don't drain anything more. Yeah, okay, fine. Open tunnel response. I'm not going to talk about this. This is how we handle getting an open tunnel response message. So there's a case here if it didn't open successfully, and there's a case if it did open successfully. Closed tunnel I don't think is even implemented right now. Oh, I did do something. Well, I don't want to look at this right now. And then just print out an unknown message type. Oddly, this is the only time I print a standard error. I don't know why I did that. Or rather, I don't know why I didn't do it elsewhere, but only did it here. Yeah, okay, so, okay, I went through that extremely fast. But the basic structure is, just these 3 if statements. We try to read the header, then we try to read the data, and then we try to read the message. And if at any point we don't have enough data, we don't change the state, we just return immediately from the function, and then the next time we get data, we basically pick up where we left off and keep going until we execute messages. Fine. That's enough explaining what this code does. I wanted to at least explain it somewhere in a video, so I'm glad I finally did that. I'd never want to do that again. But that's not true. I will explain this one more time, but I won't do it by sitting and walking through the code and explaining the line protocol. Once I have a pretty stable version of this, I want to rather explain the theory of what it does and how to use it, rather than the details of how the code is structured. Fine, enough. I'm sick and tired of explaining the code. Now, what I want to do is get it compiling and possibly working in Windows. So yeah, now we can finally fix this error. This should not be needed. Should be covered by oscommon.h. And let's try building it now. Oh, same thing. That's right, I do use this function, or this header in more than one place. Okay, Shift F9. Oh man. Oh my god, we have lots of errors. Warning. inet p2n redeclared. Redeclared without DLL import attribute. Conflicting declaration. Oh my god, what is going on? But where is it declared? Oh wait, previous DL import. What? From common.h25. From common.h42. Yeah. Let me check this guy and see what that is. Why isn't that working? Why isn't this working? Oh. All right. OBS is being a little finicky today for some reason. Oh, so apparently, so this was written in 2013. This was written in 2018. So apparently this function just exists already? Didn't have it in 2020 because I had this problem in 2020. Okay. Oh, man, we got lots of errors to fix. Everything's difficult. Everything's difficult. Error. Expected identifier before numeric constant. Excuse me? I wonder if it's some garbage at the bottom of WS2 TCP/IP that's... Oh, I forgot about this. What is it? This Win32 lean and mean. Yeah, Win32 lean and mean. It's ridiculous that you have to do this bullshit, but anyway. Maybe this will help. Did that do anything? No. I expected identifier before a numeric constant. What? Oh my god. Oh my god. You don't suppose that... Oh my god, no, it couldn't be. It couldn't be. Receive couldn't be a macro, could it? Conflicting declaration of C function. Oh my god. All right. We have no choice. We have no choice. Command not found? What? What? Oh my god. And then they open up another MinGW terminal. Man, what an absolute mess. No, this is the one that is now tied up forever, keeping my editor open. Man, I've never had a smooth experience programming on Windows ever. I mean, granted, I am using MinGW, and technically I should use that Visual C this or that. But, like, I mean, yeah, I know Visual Studio, like, handles all the compiler calls behind the scenes and just does a lot of that grunt work for you, but if you've ever tried to use the Microsoft C compiler from the command line, you'll understand why I just can't do it. Anyway. All right, let's see what in blazes is going on here. Oh, duh. Oh my god. How long has this been that way? This needs to be, I guess I never did explain this implement stuff. Basically, I really dislike having separate C and header files, and this is a trick I saw from STB. And basically, you have this macro that you call something like implement, and basically, if the implement is defined, then what you do is you write it such that the preprocessor will make essentially the .c file from this header file. But if it's not defined, you get just the header file stuff. So actually, I think that might be the issue I was having. I don't know why the error was so baffling, but what the heck? Conflicting. I'm not declaring anything. Oh my god, dude. Conflicting declaration of C function receive. I'm not declaring anything. Previous declaration in WinSock 2. Common.h line 25. Common.h line 42. What is going on? This doesn't make any sense. So in file included from from main.c line 37. So main.c line 37, we include common.h with implement turned on. And then common.h with implement turned on. We then, on line 25, we undef implement and then include common.h. And we get into common.h, and then eventually we include oscommon without implement defined. So we get into here. Now we're definitely in this segment, which is good, at least. I define Win32 lineamine. I include these two guys. This if 0 should get rid of that. This if and def implement holds true, so we get in here. In what universe does a define statement throw a conflicting declaration error? It's not. What is going on? Oh, wait. Wait a minute. Is there something wrong with the preprocessor? Expected identifier before numeric constant. All right, now we really have to pull out the big guns here. Actually, I don't need to put this on the... Yeah. So it gets defined here inside that WinSock thing. Oh, well, what is this? Oh. Oh. So MinGW declares its own write and read. So that's the problem. I don't know if I'll keep that. But for now, I just need to get this thing compiling. All right, yeah, did we finally fix this stupid error? Okay, great, we did. That's one error down, like 11 more to go. Warning, %d format expects argument of type int. The argument 2 has type sockfd. Oh my lord. Whatever. I don't need this. I'm not even using it anyway. Comparison of integer expressions of different signedness. Fine. I don't understand why clang doesn't give me that error, but anyway. Sock non-block was not declared in this scope. Man, you gotta be joking me. WinSock, sock non-block. We got to do this other thing. Okay, luckily I do know there is a solution for this in libevent. Thank goodness. is that? I'm not showing you my browser window, but it's okay. I'm just gonna. It's this evutil make socket non-blocking. Of SFD. Even the call, yeah. I like that lib event. It just barely stays behind calling Windows stupid. Like, listen to this. Even the call you need to do non-blocking I/O on a socket is not portable to Windows. The futil make socket non-blocking function takes a new socket and turns it into a non-blocking socket. But does it return? What does it return on error? Whatever, we'll just assume that. Well, I don't need to do it over multiple lines like this. This stockster and stockArnote are my things from oscommon.h, because that is not portable. What a pain, right? And I can't use close, no sir. I don't know, I don't care. Oh, actually, I don't think I need to do this because this go-to label here should close stuff for me. Yeah, if SFD does not equal invalid socket, we... Oh, yeah, that works, yeah, because, yeah, that should work. All right. That should get rid of that error, hopefully. SO reuse port was not declared in this scope. Jeez. Yeah. Where was I? Fine, we'll just do that in Linux. Stupid Windows. Well, okay, I shouldn't be quite so snarky here because, like, it is true that this is a Linux API that they ported to Windows, and I'll put it this way. Making your own API is, generally speaking, easier than implementing someone else's API on top of your own. So maybe I shouldn't be so snarky here. Invalid. Oh, whoops. Error. Tunnel T has no number named Bev. Oh, right, it's local event. Okay. Invalid conversion from void pointer. Fine. Okay. We're getting there. Sock non-block. Shoot, where did I do that other one? I understand it's a problem to have the same code pasted in two places. Where did I put that? Oh, here we go. Okay. Comparison. Oh. Okay. We're getting there. Jump to label, tunneler connect return from here, crosses initialization. Fine. Where does that go to? Oops. Okay. Sock non-block. Wait, I gotta do this again? Man, I should really put that in a function. Where did I even do that? Yeah, this is what I want. Yeah, I should really put this into a common function. Should I do that right now? I really don't want to. Okay, we're getting there. I should probably use CLock anyway. Invalid conversion. Oh, right. This needs to be a sock FD. Huh. Maybe it's that. Yeah, futil socket type. And actually, yeah, okay, I did make these sock FDs. I should probably make this futil socket type. Whatever. Jump to label from here, process initialization. Ugh! Man, I was getting excited. Undefined reference to all of these things. All the Lua functions. Oh my god. Oh my god. Oh my god. Oh my god. Okay. First, let's just see if that. Shoot. Oh, it's WS232. Oh, man. God. I need to figure out how to make this makefile work, depending on whether it's Linux or Windows, which is such a pain. Such a pain. Undefined reference to Lua new user data. Why? God. Oh, God. Man, where do you suppose that either .lib or .dll file lives? Like, uh God. Mingy, I don't know. Let's try msys Lua compile whatever. Oh, maybe I need Lua 5.4 because the DLL says 5.4 on it. No. Undefined reference. But why? Alright, hold on. We got some stuff to do here. Okay, view. No. Edit? Where's the line wrapping? Document. Line wrapping. It's all the Lua functions. Why can't it find that? Dude, I don't even know, like, I didn't write this make file, it's just the one that came with Replit. Man. Alright, what is it that you're seeing on the other window here? Okay, that is what I wanted you to see. Mingy W64 lib? Okay. I don't understand. It exists, doesn't it? I don't get it. What's the problem? God. But it's all there. Alright, let's just pick one of these here. Let's do Lua new user data UV. What does T mean again? T. The symbol is in the text code section. Okay, great. Then what's the problem? Why can't this... God, you gotta be joking me, dude. Alright, let's just try... G plus, I don't know, GCC. Oh wait, why am I using G++? I don't know why I did that. It's a weird decision on my part. Oh man. Conflicting types. Forget time of day. Maybe even GW really is improving. Ah! No way! No way! Ooh, but it died immediately. Why? Oh my goodness. Hello. Oh, okay, it just came back to me. I was looking at something on my phone while I was waiting for it to finish. Now, I think GDB is broken. Yeah, well, whatever. Go. Oh my goodness. It didn't even run the event loop. Okay, something is deeply wrong. Just stop. Just stop. What if I try my other non-broken terminal window? The DaVinci W terminal window for some reason is broken, but I have this other. I installed Git for Windows like years ago, and it came with a super nice terminal that I use for everything because it works really well. And it turns out it is MSys, or like a small version of MSys, but like a non-broken one. Let's try this terminal window. Lib event. Yikes. Oh man. God. Everything is painful on Windows. I think it's because I have a certain folder on the path in the other terminal. Oh, you can't see what I'm doing. Shoot, I forgot. Let's go here. See if I can find that DLL in one of these paths. Okay, I found it. So, now, where the hell is this? Oh man, where do you suppose that is? just going to search for this file from my C drive and see if I can find it. I'm using Windows Explorer to do it. I may as well show you the window. Why not? Whoa. Whoa, dude, this is so cool. Oh man, I gotta try and show you this. There's something happening outside my window. How does one do this? For that. Okay, there we go. That's really cool. Come on, you can do it. All right. No. Oh, wait. I just had an idea. I think if I do this, it'll just give me the path. Yeah. And I guess Lua was just statically compiled into it. Ah, no, but it's giving me the... Oh my god. Alright, okay. I gotta find this stupid thing. Windows Find is not working for me, so... Where did I install MSys? Oh, hey, wait a minute. I can include live events statically, can't I? Let's try that, actually. Okay. No. Yeah, let's try including it statically, see what that does for us. It's probably a bad idea in general, but I don't know. Nothing to be done. Okay, well, let's give you something to do. Undefined reference to IF name to index. There's another file in that folder called this. Oh, that just randomly worked. All right, now let's try this. No. Okay. Okay. Ugh. All right, well that didn't work. So let's put this back the way it was and see if I can track down that stupid DLL. Man, this is just not gonna work, is it? Ah, man. Well, okay, there is something else I can do. So check this out. I'm gonna do this, and then that. Okay, so check this out. So LSC. Okay, that works. MSys 64, MinGW 64. Lib. So you see there's a, here, let me just grep this for event. There's a bunch of these. Let's just put all of these onto the command line. I mean, now we're really getting desperate. Oops. Okay. Excuse me. Main.d. What is this .d junk? Like, just. Why is this broken now all of a sudden? All right, fine. Let's. Oops. Oops. I don't know why that fixed it. That didn't work, did it? Yeah, same thing. It could also be the kind of thing where, like, you need to put these in the right order. Undefined reference. Let's try putting this last. Undefined reference. Yeah, it's not gonna work. It is nice to put Lua in statically. That kind of saves me a lot of headaches. So now, but at least now I know where that DLL is. LS, C, MSys64. Oh, shoot, though. Oh, man. I'll betcha. Yeah, 1 second. Oh, man, this is such a nightmare. So let me show you why I'm upset. Okay. So if I do no. Wait, what? Oh, right. I actually need to. So that's okay, that's okay, that's okay, that's okay. This probably okay, that's okay. This is the one that's an issue, but that should be good, that's good, that's good, that, ooh. Yeah, that's good, that's good, that's good, good, good. Maybe not good. But I'm not using threads here, am I? What happens if I just get rid of that? Yeah, okay. Now, why is that still asking for threads? Let's just start taking off some of these flags that that Replit put on for us. Now, why is that still asking for libwinp thread? Man, I don't know. But anyway, the reason why I'm upset here is because I have a feeling that this guy is going to drag in a bunch of junk. Well, what's the worst that could happen? Let's go over here. Let's do now let's do C MSys64 MinGW 64 bin. Oh, okay. Well, that's progress. Now I think GDB actually does work. What? I thought this was working before. Well, fine. We just have to live with it. Where is that? So I want to break on this read standard in callback, which I think is just not even getting called in the first place. Oops. Okay, run. Yeah, it doesn't even get called. Why? Why? Maybe if I check the return code from event-based dispatch. Let me check the libevent docs. Oh, I guess I should show you that, shouldn't I? No. This task keeps running until. Okay, the same. So let's check what the return code is. But it doesn't say what the return code is supposed to be. All right, let's see if I can actually open up that file. So that would probably be inside msys MinGW64 include event. Oh man, what file would that be in? Event.h. Event base loop. Okay. Waits for events to run their callbacks, more flexible. No more pending events. Return 0 if successful, -1 if an error occurred, or 1 if we exited because no events were pending or active. Okay, it would be nice to know what the error is, but let's start with that. Whatever. Okay. I guess I could have figured that out in GDB, but -1. Well, now what's the error? How am I supposed to know what the error is? That's got to be in the docs somewhere, right? Oh, libevent can log internal errors and warnings. It also logs debugging messages. To standard error, you can override this behavior by your login function. All right, let's try this. Nothing. That didn't work. Oh, duh, no. What am I doing? I thought it's the kind of thing where it turns on if you, but that doesn't make any sense because like I'm using a precompiled. Okay, let's just do that set event callback thing. Void print event message int severity char const pointer message, and here we're just going to put us the message, like whatever, man. And then we can do event set log callback is just global. Okay. Nothing. There's no Oh, I guess you can't see my terminal, but it's just here. Let me do this. Whatever, forget it. I was gonna try and run it using Genie, but it's just returning -1, and I don't know why. So how do I? All right, event enable debug mode. Help. I need help. Why isn't this working? Nothing. It's not printing anything. Maybe the source code is included. Actually, why don't we just go find the source code online? I'm sure I can find it easily enough. Okay. So that'll probably be in event.c. Okay. That's probably not it. Oh man, event debug. If it's not printing debug messages, then it doesn't set any errors. It just, oh man. All right, wait. There's another trick I can use though that will hopefully work. Man, which terminal am I using? One thing I could try. No, nothing at all. You don't suppose libevent has debug symbols in the version I installed with MSys. Okay. Oh, incomplete type. Oh yeah, no, dude, we're boned. We're not gonna get any help from this at all. Yeah. Man, this is why I really don't like programming in Windows. So the only other option I have right now, and that's not going to be something I'm going to do right now because I'm already at the end of my wits. I could download the source code and compile my own version of libevent. How bad could it be? How bad could it be? How bad could it be? Fine, let's just do it. Let's just try it. Let's go to, where's the releases? Of course, it's a gzip file, so I got to figure out how to undo that on Windows. CD tar-xzf, maybe? What is that called? Lib event. Oh, wait. Hold on. How come I have... Wait, how come I already have it? Have I done this before? Nothing. Oh, man. How do you suppose I compile this? Oh, man. It uses automake. I can't remember how to use automake. How do you... autogen.sh. Oh my god. Oh, I'm gonna regret this. It's gonna dump it all. Oh, actually, it wasn't going to in the end. Yeah, this is exactly the same thing I had. Oh, wait, CMake. Okay. Maybe we're not boned. How does one do this? Shoot, I always forget how to use CMake. CMake. Whoops. Build. Okay. Maker CMake -b build. Hey! Oh, wait. The C compiler identification is unknown. Okay, let me open up my other terminal, which is the MSys64. I know. Oh! Everything has to be so complicated. MSys CMake. You think that's the right one? Betcha it isn't. MinGW64. Yeah, this is probably the one I need. Yeah. Just give it to me. I have to admit, the Pac-Man integration in MinGW is really nice. It's like the #1 super nice thing. I just like having to have all these different terminals with different specific environments, but at least that is provided. Can you imagine if it wasn't? Oh my God. That, I mean, it used to be the case that it would just all go into your regular environment, like in your CMD environment, basically, and that was a nightmare. So this is a better solution. Signature is unknown. File blah is corrupted. Do you want to delete it? Sure. Well, that's going to close my editor, but that's okay. Yeah. We're going to get there. We're going to get there. Man, what is going on? I really hope this works this time. I mean, it is amazing that MinGW works at all. I mean, just the scope of the work needed to make MinGW and MSys possible is unimaginably large. And I think it's only worked on seriously by like a very small team. I mean, they have a lot of contributors, mind you, but it's like it's some deeply complicated computer stuff that like, oh hey, that works, nice. But yeah, it's like I think I could do it. Like I think if I had about a year, I could learn to maintain MinGW. Like a year full time, I think I could do it. Anyway, maybe more. But okay. What? What is going on? Like is it? Is like standard error broken or something? Whoops. Oh my god, dude. Ugh. What? What? How come it doesn't print anything? Oh, dude, you gotta be joking me. I mean, I can't do anything if it doesn't tell me what's wrong. What? Oh my, okay, that works at least. All right. So it's just CMake that's broken. I think I'm boned. I'm out of options. I don't understand. How come nothing is printing? I'm running low on ideas. First, let me open up my editor again. Ugh. Man. And Nah, man, I don't know, man. I got no ideas. I'm just out of ideas.